Welcome to Math Simplified for 9th Standard. We are studying the 5th chapter, Coordinate Geometry. We are going to study the topic Midpoint Formula today. The exercise is 5.3. Please subscribe and share with your friends also. Question 1. Find the midpoints of the line segment joining the points. So these are the 2 points. They have given us the coordinates. Okay, first let us know what is this midpoint formula. Okay, for A, x1, y1 and B, x2, y2, the midpoint of AB, this line segment AB, is given by the letter M, capital M. The coordinates of this point M is x and y, okay, is equal to x1 plus x2 upon 2 and y coordinate is y1 plus y2 upon 2. Okay, so once again I repeat, let A and B be the 2 points and M is the midpoint of AB. The coordinates of A is x1, y1, B is x2, y2. Then coordinates of the midpoint M, xy is equal to x1 plus x2 upon 2, comma y1 plus y2 upon 2. Okay, now let's go to the sum. It will become very easy. So this x1, y1 is this values, x2, y2 are these values. So let's find the coordinates of the midpoint of these two, this line segment. Okay, so here it is. M is xy is equal to x1 plus x2 upon 2. So what is the x coordinate here? x1 plus x2 upon 2. So here minus 2 plus minus 6 upon 2. And what about the y coordinate of the midpoint? It is equal to 3 plus minus 5 upon 2. Let us simplify this. Minus 2 plus into minus is minus, minus 2 minus 6 is equal to minus 8 upon 2 and y is equal to minus 2 upon 2. This is minus 4, this is minus 1. So the midpoint is minus 4 comma minus 1. Okay, let's go to the next sum. So here these are the 2 points. We want to find the midpoint of this line segment. Okay, so here let's write down the midpoint formula like this. So here x1 is 8, x2 is minus 8. So 8 plus minus 8 upon 2, comma minus 2 plus 0 upon 2. That is the coordinates of the midpoint. This is equal to, simplify this, 8 plus minus 8. So plus into minus is minus, 8 minus 8 is 0, 0 upon 2 is 0. Minus 2 plus 0 is minus 2, minus 2 upon 2 is minus 1. Okay, so these are the 2 points here. This is x1, y1, this is x2, y2. Okay, so let's add. So mxy is equal to x coordinate a plus 2b upon 2, comma b plus 2a minus b upon 2. Simplify this, you'll get like this. Again 2 take out common and you can cancel it. You get a plus b comma a. Fourth sum. So these are the coordinates are in fractions. Don't worry about it. Just write down the formula. This is x1, this is x2. So x1 plus x2 upon 2, comma y1 plus y2 upon 2. Now you can simplify these fractions. I've simplified it here for you and you will get the answer as 1 comma minus 1. Nothing, it's very simple. You just have to take the LCM here, that is 2. So it will come down like this, 1 plus 3 upon this LCM, 2 here, 2 into 2, comma. So here also LCM is 7, write it in the denominator, minus 3 minus 11 and here you multiply this LCM with 2. Simplify it further, you'll get the answer. Okay. The center of the circle is minus 4 comma 2. If one end of the diameter of the circle is this, then find the other end. Okay. Here what they have done, they have given us the value of mxy. That is the midpoint. Okay. This is the midpoint. And one end, that is a x1, y1, they have given us. And we are asked to find b, x2, y2. Okay. It's the same thing, simple. Just write down the formula first. Here we know the value of x. Okay, we have to find the value of x2. Okay, what is the value of x? Minus 4. Put minus 4 here. Okay, x1 is minus 3. x2, leave it as it is. Write down upon 2. Similarly here, what is y2? y1 is 7. y2, leave it as it is, upon 2. Okay. Now simplify this, you will get the value of x2 and y2. So the point is minus 5 minus 3. Okay. So the 2 points are A and B, and the midpoint is this. Question 3. If the midpoint xy of the line joining these 2 points lies on this equation, then what will be the value of P? Okay, let's first find out the midpoint. mxy is equal to x1 plus x2 upon 2, comma y1 plus y2 upon 2. This is x1 y1 and this is x2 y2. So x is equal to 3 plus p upon 2 and y is equal to 4 plus 7 upon 2. So 2x is equal to 3 plus p and 2y is equal to 11. Now this point, actually this midpoint lies on this equation. So let us substitute here these values in this equation. So here write down the values. 3 plus p plus 11 plus 1 is equal to 0. You get the value of ps minus 15. Question 4. The midpoint of the sides of a triangle are, these are the midpoints. Find the coordinates of the vertices of the triangle. The sum is very simple. Just listen carefully, you will easily understand it. Okay, what they have done is, this is a triangle. They have given us the midpoint of the sides of the triangle. So these are the points 2, 4, 5, 2, minus 2, 3. Okay, they are asking us to find the coordinates of the vertices, that is A, B and C. Okay, so here let us say that the coordinates of A is x1, y1, B is x2, y2, C is x3, y3. We have to find the values of these coordinates. Okay, x1, y1, x2, y2, x3, y3. Okay, now let's take this side. So we are going to put the midpoint formula here. x1 plus x2 upon 2 is equal to 2. So here it is x1 plus x2 upon 2 is equal to 2. Similarly here minus 2 is equal to y2 plus y3 upon 2. Okay, and here 5 is equal to x1 plus x3 upon 2. Okay, simplify this, you get like this. x1 plus x2 is equal to 4, x2 plus x3 is equal to minus 4. Multiply this denominator on the other side, and x3 plus x1 is equal to 10. Now these three expressions we are going to add them. Okay, so when you add, you will get 2x1 plus 2x2 plus 2x3 is equal to 4 minus 4 plus 10, that is equal to 10. Okay, simplify it further, you get this expression x1 plus x2 plus x3 is equal to 5. This is the equation 1. Now with this, we are going to find the values of x1, x2 and x3. So for that, you again go back to this expression. x1 plus x2 is equal to 4. So put here 4, x1 plus x2. So 4 plus x3 is equal to 5. So x3 is equal to 5 minus 4, that is equal to 1. Okay, now again let us substitute this x2 plus x3 in this equation. Okay, x2 plus x3 is equal to minus 4. So minus 4 plus x1 is equal to 5. So x1 is equal to 5 plus 4, that is 9. Similarly, the third equation x3 plus x1, I am going to substitute in this main equation. Okay, and I can get the value of x2. x2 is equal to minus 5. The same way you have to find the values of y1, y2 and y3. Similarly, you have to write down y1 plus y2 is upon 2 is equal to 4. y2 plus y3 upon 2 is equal to 3. y3 plus y1 upon 2 is equal to 2. and then you should simplify it and add up the three expressions, whatever you get. And if you do this, you will get the values of y1, y2 and y3. And we will get it as 3, 5 and 1. I'll leave that to you. Please practice it. Okay. So now you got x1 as 9 and y1 as 3. So A coordinates is 9, 3. B, x2 is minus 5, y2 is 5. So minus 5, 5. C, x3 is 1, y3 is also 1. So these are the vertices of the triangle. Okay, please practice this sum. It's very easy and you can score full marks in it. Question 5. If O00 is the center of the circle whose one chord is AB, where the points A and B are these 2 points respectively, OD is the perpendicular from center to the chord AB. Find the coordinates of the midpoint of OD. Okay, so here the question is that we have to find this M. Okay, so here we have the center of circle, which is 0, 0 coordinates. This is the chord AB. This is the perpendicular on the chord. So we know that this is the midpoint of this chord. Okay, we can use the midpoint formula and find the coordinates of D first. And once we know the coordinates of D, this coordinate also we know. Again, we will use the midpoint formula and find out M. Okay, very simple sum. So let's do it. So A this is the coordinates, B is this, and midpoint of AB is dxy. Okay, so what is the midpoint? What is the value of x? X is equal to 8 plus 10 upon 2, that is equal to 9. Y is equal to 6 plus 0 upon 2, that is equal to 3. So the coordinate of D is 9, 3. Coordinates of 0 is 0, 0. O. Coordinates of O is 0, 0. So now again do the midpoint formula for this. So x coordinate of M, remember that, x coordinate of M is 0 plus 9 upon 2, that is 9 upon 2, and coordinates of y is 0 plus 3 upon 2, that is 3 upon 2. So mxy is equal to m 9 by 2, 3 by 2. Question 6. The points A, B, C are the vertices of an isosceles right angle triangle where the right angle is at B. Okay, so this triangle is an isosceles triangle. That means two sides are equal. AB is equal to BC. And this angle is a right angle. Okay, find the coordinates of D so that ABCD is a square. So we want to find out a point D like that, such a way that this is a square. Okay. Okay, in a square, the diagonals, they bisect each other. That means, what is the diagonal here in this? AC. Okay, and the other diagonal is BD. So the midpoint of AC is the same as the midpoint of BD. Okay, that is the property of a square, that they bisect each other. Okay, so now let's solve the sum. Let dxy be the fourth point, and we are going to find the coordinates of this point. Okay, now midpoint of AC is equal to midpoint of BD. Why? Because it is a square. Okay, so first let us write down the midpoint of BD. Okay, so here it is minus 1 plus x upon 2, comma, minus 2 plus y upon 2 is the midpoint of BD. And it is the same, is equal to minus 5 plus 5 upon 2, comma, 4 plus 2 upon 2. So, okay, now x coordinate is equal to this. So, minus 1 plus x upon 2 is equal to 0 upon 2, and minus 2 plus y upon 2 is equal to 6 upon 2. Now simplify this, you get the value of x as 1. Simplify this, you get the value of y as 8. So D1, 8 is the fourth point to make this a square. Question 7. The points A, B, C are the midpoints of the side of DE, EF, FD of a triangle DEF. So here D, E and F is the triangle, and we do not know the vertices, so we are writing x1, y1, x2, y2, x3, y3, and these are the midpoints. A, B, C are the midpoints of these sides, and the coordinates of the midpoints are given. Okay, what we have to prove is that A, B, C, D is a parallelogram. Okay, so here we have to prove that the midpoint of this diagonal is the same as the midpoint of this diagonal, just like in that square, the previous sum that we did. Okay, so to find the midpoint of this is easy. We can apply the midpoint formula. But here we do not know, because we do not know the values of this. X1, Y1 we do not know. So first we have to find out X1, Y1. Okay, for that, I think in question number 4 we did that sum, how to find the vertices of a triangle when the midpoints of the sides are given. Okay, let's go through that once again. What did we do in that? We have considered this as the vertices. Then what did we do? X1 plus x2 upon 2 is equal to minus 3. x2 plus x3 upon 2 is equal to 0. x3 plus x1 upon 2 is equal to 1. Write it down. Simplify it. Add these expressions. You will get like this equation. Now substitute this here. You will get the value of x3. Substitute this here. You will get the value of x1. You will substitute this here. You will get the value of x2. So here we got these values. Similarly, do for the y coordinates. So, okay. But we are mainly interested in the x1, y1. Okay. x1, y1. So, here it is. We found the y coordinates also. x1, y1 is minus 2, 8. So, we got this coordinates. Now, let us put this. Let's find the midpoint of this now. So, midpoint of DB is minus 2 plus 0 upon 2, that is minus 1. 8 plus 7 upon 2, 15 by 2. Similarly, find out the midpoint of CA, this diagonal. This is what you can see, both are same. So, the midpoint is the same for both the diagonals. Therefore, ABCD is a parallelogram. Question 8. A, B, C are the vertices of a right angled at A. Show that the midpoint of the hypotenuse is equidistant from the vertices. Okay. So here they are saying that it is a right angle triangle, and these are the coordinates, and this right angle is here. This is the hypotenuse. Okay. So let M be the midpoint of the hypotenuse. So what are the coordinates of this hypotenuse? Of this midpoint of the hypotenuse, it will be minus 3 plus 3 upon 2, comma, minus 2 plus 2 upon 2. So, both case it is 0. So, mxy is equal to m0, 0. Okay, we found this coordinates. Now, we have to show that the midpoint of the hypotenuse is equidistant from the vertices. So, equidistant, that means this distance is equal to this distance is equal to this distance. So, these are the 3 vertices, and M is at an equal distance from the 3 vertices. So, let's find out CM by distance formula. You know distance formula, square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So, that is the distance formula. So, let us apply AM. Okay. So, here minus 3 minus 0. This is 0 whole square plus 2 minus 0 the whole square. Simplify it, you get root 13. Similarly, CM here. Minus 3 minus 0 the whole square plus minus 2 minus 0 the whole square. Simplify, root 13. Similarly, for BM, it will be root 13. So, here AM is equal to CM is equal to BM. So, the vertices are at an equidistant from the midpoint of the hypotenuse. Here we come to the end of the exercise. Please go through the exercise once again. Pause the video in each sum and practice them.